Now we're at the last segment of our review, and we're solving systems of equations. So what we want to do is we want to add these equations together, and we want to cancel out an x column or a y column. Now at the moment, neither the x's nor the y's will cancel if we sum the equations. So what we're going to do is we're going to multiply both sides of one or both equations by a number so that we do get either x coordinates or y coordinates that cancel. All right, well, let's look at the x coordinates. The x coordinates are 2 and 4, and the y coordinates are -3 and 5. In order to get the same coordinate here in the x column with opposite signs, we just have to multiply the first equation by -2. All right, and we'll get a -4 here, and we have a 4 here, so when we add, we'll get canceling. Now, if we tried to cancel the y column, we would have to multiply both equations by a number to get the same coefficient here with opposite signs. All right, so we'll do the x column. Let's multiply the first equation by -2, and we do that left and right. And now rewrite the entire system. So here, this first equation is -4x plus 6y is equal to 8. And the second equation is 4x plus 5y is equal to 14. All right, now we'll add these together, and now we arrange things so that when we add the x column, we get the x terms canceling. Here we have 11y is equal to 22. And just divide by 11. And we have y is equal to 2. So that's the y coordinate of the solution. In order to get the x coordinate, we'll substitute y equal 2 into, let's say, the top equation. We could use the top or the bottom. We'll get the same x coordinate if we do that. All right, so now what we're going to do is we're going to substitute y equal 2. We'll do it in the first. So we have 2x minus 3 times 2, that's 6, is equal to -4. And let's say add 6 to both sides. And we have 2x is equal to 2. Now divide by 2. And we have that x is equal to 1. So there's the x solution, and there's the y solution. Sometimes we write this in point form. X is 1 and y is 2. Here's another system of equations, and we want to eliminate either x or y. So if we look at the x column, let's see, we have coefficients 3 and 5. If we look at the y column, we have coefficients -2 and 3. All right, so we have to decide if we're going to eliminate x or y. I think I'll eliminate y because we already have opposite signs here. Now, to eliminate y, we need to have the same coefficient here with opposite signs. So that coefficient is going to be the smallest number that 2 divides into and 3 divides into, which is 6. So we're aiming for a -6 here and a 6 here. All right, so we have to multiply the top equation by 3 left and right. And here also by 3. And the bottom equation by 2 left and right. Now let's rewrite. We have 3 times 3 is 9, 9x minus 6y is equal to -27. And the bottom equation, 10x plus 6y is equal to 8. Okay, so we get a 19x when we add the x column. These cancel. That's the way we arranged it. And here we have -19. And let's divide by 19. And we get x is equal to -1. Now let's find y by substituting x equal minus 1. I'll do it in the first equation, and we have minus 3 minus 2y is equal to negative 9. Okay, solving for y, we'll add 3. And we have 2y is equal to minus 6. Divide by 2, and we have y is equal to minus 3. So that's our x solution and our y solution, and in point form that would be minus 1, minus 3. All right, in question 3, the instructions are a little bit different. Here we're asked to find the x value. All right, so we only need the x value. We're not going to find the y value. So if we're asked to find the x value, that means we want to eliminate y. Find x, that means eliminate y. So we look at the y column, and we see that we just need one multiplication here. We can multiply the top equation by negative 2, and we'll get a coefficient of minus 6y, of minus 6. In the bottom equation, we have a coefficient of 6, so that would be good. So let's multiply the top equation by negative 2. Okay, let's rewrite now. So we have minus 10x minus 6y is equal to negative 10. And the second equation, 7x plus 6y is equal to 4. And now let's just add these together. So here we have minus 3x. The y column cancels, is equal to minus 6. And now we'll just divide by negative 3. And we get that x is equal to 2. And we'll stop there because we're only asked to find the x value. Number 4 uses function notation. So number 4 reads, find f of minus 2, where f of x is equal to 3 minus 4x over x minus 5. So we have an equation, and instead of writing y equal, we write f of x equal. And this notation, f of x, it really denotes a y value. It's the same as a y value. But it has the x built into the notation, so it means the y value that corresponds to a specific x value. So for example, this is the y value that corresponds to x equal 2. That's how you can think of this. We're asked to find f of minus 2, and basically that just means substitute in minus 2 for x. Okay, so let's do that. So f of minus 2 is equal to, here on the left side we put in a minus 2, and we put in a minus 2 on the right side as well, wherever we see x. Okay, that's f of minus 2. Let's just figure out what this is. This is 3 plus 8 in the numerator. And then we have a minus 7 in the denominator. So f of minus 2 is equal to 11 divided by minus 7. Okay, so that's the y value that corresponds to the x value of minus 2. Okay, number 5 asks to find the domain of, we have 3 functions here, a, b, and c. Okay, starting with a, we have f of x is equal to x over x plus 3. Now let's remember what the domain is. The domain we can think of as all possible x values. Okay, all possible x values that can be substituted in, and that will yield a corresponding y value. Well, we can really substitute anything into here, except we have to be careful not to divide by 0, or not to get 0 in the denominator. So if x is equal to minus 3, then in the denominator we have minus 3 plus 3, which is 0. So we just have to be careful not to substitute in negative 3. And that's really what our domain is. Usually we use a uppercase x to indicate the domain. So we can write that the domain is all x values except x cannot be equal to negative 3. Okay, and that's the domain. All x values except x cannot be equal to negative 3. In 5b, again, we're finding the domain. And once again, we have a denominator, so we want to make sure that the denominator is never 0. In other words, we don't want to substitute in an x value that makes the denominator 0. So when is x squared minus 25 equal to 0? Well, in order to see that, we have to first factor the denominator. So let's do that. Let's factor the denominator. And we have x plus 5 times x minus 5. So now we see that we should not substitute in x equal minus 5 because that'll make this term 0. And we shouldn't substitute in x equal 5, which makes this term 0. So if x is equal to minus 5 or 5, then we'll be dividing by 0. All right, so let's make sure that x is not equal to minus 5 and x is not equal to 5. So basically that's our domain. All x values except x cannot equal to minus 5 and x cannot equal to 5. Okay, 5c has a different type of function. We don't have a denominator, but we do have a square root. So in order that f of x is a real number, we have to make sure that the square root is, underneath the square root, we have a quantity that is greater than or equal to 0. Because the square root of a negative number is not a real number. So we're just going to solve this little inequality, 2 minus 5x. We want to make sure that that's greater than or equal to 0. Okay, so let's solve for x. Subtract 2 from both sides. We have minus 5x is greater than or equal to minus 2. And now divide by minus 5, and here we're dividing an inequality by a negative, so we must switch the direction of the symbol. So we have x less than or equal to minus 2 over minus 5, which is the same as 2 over 5. And that's our domain. So if we choose an x value less than or equal to 2 over 5, then this quantity is going to be positive. Like, let's suppose we chose x equals 0, for example, then we'll be taking the square root of 2, so that's fine. Or if we chose x equal minus 1, then we'll be taking the square root of 2. Minus 5 times minus 1, that would be 2 plus 5, or the square root of 7. So that would be positive as well. So anything less than or equal to 2/5 will give us something that is greater than or equal to 0 underneath the square root, and we'll have a real number. Well, that's the end of our review for the final exam. So I would suggest that you do these problems on your own, check your answers, and also do the review sheets that we had for the 4 exams. All right, and if you do all those problems, then I think you'll be very well prepared. Okay, so good luck with your studying.